Hi, I'm Dimitris Charalambidis, and in this presentation we'll talk about solving linear systems by opposite coefficients. Let the system that contains the two equations 2x plus 3y equals 5 and 3x plus 5y equals 8. We will now see how we can solve this system by applying the so-called method of opposite coefficients. In order to help ourselves during this solution, we can name from the beginning these two equations as 1 and 2 respectively. Now, in order to solve this system, we have to follow some steps. In first step, we decide which one of the two variables we want to send away. And this is a decision that is done only by us. We actually decide which variable we want to send away. It could be any variable. Let's suppose now that we want to send away the x variable. Next, in step 2, having decided from step 1 which variable we wish to send away, we apply the following thinking. We multiply each equation with such numbers so that the variables we wish to send away, after these multiplications, get to have opposite coefficients. Remember that we initially had the system that contained the equations 2x plus 3y equals 5 and 3x plus 5y equals 8. Remember also that we decided in step 1 to send away the x variable. So, one way we actually do that is we multiply each equation with the coefficient of the variable we want to send away of the other one. To explain it a little further, we will go and we will multiply the equation named as 1 with the coefficient of the second equation. So we'll multiply equation 1 by 3. This multiplication will give us a new equation which will be the equation 6x plus 9y equals 15, which we will now name as third equation. Then we will return to the second equation, and this time we will multiply it by the coefficient of the first equation in the x variable. So we decide that maybe we could multiply the second equation by 2. But if we actually multiply the second equation by 2, this will give us 6x. But since we want to have opposite coefficients, we will decide to multiply the second equation by negative 2. This new multiplication will indeed bring us a new fourth equation, which will be negative 6x minus 10y equals negative 16. And you can see that from the system that contained the equations 1 and 2, we go to a new system that contains the equations 3 and 4. But this time, these new equations have something we wanted from the beginning. The coefficients in the x variables are opposites. Then we move in third step. This is the step where we actually add the two new equations we got from step 2. After we add these two equations, we have to solve the equation that is created by this sum. Indeed, if you take a look in the diagram in front of you, you can see that this addition gives us negative y equals negative 1. Thus, y is equal to 1. So far, we managed to find the value of y we wanted for our solution. In fourth step, we substitute the value of the variable we found from step 3, in our case y equals 1, in any equations we want to find the value of the other variable. So, like I said, we will go to any equation we want. Let's say in the first equation, we will plug in 1 in place of y and just solve for x. By doing that, we get that 2x plus 3 times 1 equals 5, which, after some simple operations, leads us to x equals 1. In fifth and final step, we can give our answer as a point, as a pair of solutions. So, the pair of solutions for our initial system will be 1.1. Otherwise, the solutions to the initial given system are x equals 1 and y equals 1. For any questions about this presentation, you can leave comments down below or you can contact me with one of the following ways. As always, thank you for your time.